Cognitive Control in Media Multitasker, author Erald Clifford Anthony, Passenger Daniel He. Media multitasking, which is a person's consumption of more than one item or stream of content at the same time. And it is becoming an increasingly prevalent phenomenon. However, it's unknown whether and how chronic heavy multitasker perceive information differently than individuals who do not frequently multitask. Therefore, the goal of this research is to examine the relationship between chronic media multitasking and cognitive control abilities. One possibility was that if chronic media multitasker have advantage in cognitive control, which can promote future research to focus on this hypothesis. Alternatively, if the massive media multitasking behavior is related to cognitive control deficits, this may lead to an important aspect of causality. The change in multitasking behavior can be justified if chronic media multitasking is the cause. So here are the questions. Are chronic multitasker more attentive to irrelevant stimuli in the external environment and irrelevant representations in memories? So the research looked into three aspects in detail. First, filtering environmental distractions. Second, filtering irrelevant representations in memories. Third, task switching. There are 262 university students participate and asked to complete the questionnaire to divide into two different groups. The questionnaire addressed 12 different media forms, such as computer, games, online video, web surfing, SMS, etc. Participants were asked to report the total number of time has spent for each medium per week, where M is the number of media typically used, and H is the number of hours per week reportedly spent using primarily. And the I and H total is the total number of hours per week spent with or primary media. For those students with MMI less than 1 standard deviation or more below the mean, they refer as LMMs, light media multitask. Students with MMIs greater than 1 standard deviation or above the mean refer as HMMs, heavy media multitaskers. The third aspect is filtering environmental distractions, which is to test the filtering ability to can point to brief orientations in allowing stimuli into working memory. There were two tasks for demonstrate this part, which are filtering task and ASCBT task. In the filtered task, the participants were asked whether the red rectangles have changed among the blue rectangle distractors. The first cue lasts for 200 milliseconds, and the first arrays present in 100 milliseconds for participant to memorize. After the target gone wait, it leaves blanks for 900 milliseconds. And then the second arrays present in 2000 milliseconds for participant to indicate change. As you can see here in the graph, the red rectangle in the task array is different from the memory array. So there's the change. Then press yes button. Otherwise press no. In order to measure the filtering effectiveness, the number of blue rectangle will be different in number of 0, 2, 4, 6. And the number of red rectangle will be different in number of 2, 4, 6, 8. But the total number of rectangle cannot go beyond 8. So the total will be 8 in the bust. After the experiment, the researchers have conducted a result that showing HMM's performance is negatively affected by distractors. As you can see in the graph here, the HMM have significant drop down when number of the distractor increased. The second task is ASCBD task. In the ASCBD task, the participants were asked to see the sequence of letter present in 300 milliseconds in red color on the black screen. There are 3 additional distractor letters in white color, which can be any letter but not A, X, K, Y. The black letter in the graph were present in red in the experiment. As you can see, there are distractor in between Q and probe. They are also present for 300 milliseconds with 1,000 millisecond intervals between Q and first distractors and between each distractors. When the red Q8 follow with red Pro X, press yes. Otherwise, press no. Pretty straightforward. A, X, yes. B, X, note. A, C, note. And lastly, B, C, note. The ASCBD test consists of 2 parts. That one is standard AXCBT, and the other one is AXCBT with distractors. The standard AXCBT task is without distractors, so you can ignore the white letter distractor in the graph here for the standard ASCBT task. The result from this task indicate that no significant difference between HMMs and LMMs in the standard AXCBT task. HMMs were 77 milliseconds slower to respond to the probe in ASCBT with distractors, as shown in the graph. Moreover, HMMs were 84 milliseconds slower than LMMs in AX trials. HMMs were 190 milliseconds slower than LMMs in BX trials. It takes longer time for HMMs to process. The AXCBD data showed similar results as the filter task, which demonstrate HMMs are less selective in allow information into working memory and more affected by distractors. The second aspect is to look at the research is filtering irrelevant representation in memory, which examine the monitoring and updating of multiple representations in working memory. And 2 and 3 back task is used for the aspect. It also named M-back task. In 2 and 3 back tests, participants were asked to represent a series of individual letters. Each letter will present for 500 milliseconds, followed with white screen of 3,000 milliseconds. Then they were asked to indicate whether the not present letter was target, which matched the letter present 2 or 3 trials ago. Another straightforward experiment. As you can see, the top row is present 2 back task. When the target D present, and it's matched to the queue 2 trials ago, and I press the target button. If the queue D is not matched to 2 trials ago, like D is in here, it didn't match 2 trials requirements, then press non-target buttons. Same for the 3 trials task. The result from this test indicate both HMMs and LMMs showed similar decrease in heat rates. The number of target correctly identified, which is heat rate, and HMMs show greater increased in false alarm rate. The number of non-target incorrectly marked as target, especially in 3-back task. HMMs have trouble with interference similar items, which increased working memory load. The effect of false alarm was driven by target letters and had previously appeared during the task, but were outside the range participants were instructed to hold in memory. Which that means is participants were asked to respond to target D, but they were still thinking in responding to C. The results demonstrate HMMs are less able to filter out irrelevant stimuli from environment, and also less capable to filter out irrelevant representation in memories. The third aspect is task reaching. This is task participant ability to task set reaching. The task for this aspect is number letter task. In number letter task, participants were presented with one of 2 cues for 200 milliseconds, either number or letter, following by stimuli that consists of digit letter pair 2B, such as 2B or B2. The order can be reversed. As you can see in the graph, when the cue is letter, then you see a digit letter pair with consonant. Then you press right button. To repeat the trials, Q is letter again. See the digit letter pair is vowel, such as you see here. If here is 8, then you press left button. Same for the number cues. You see even, you press right button, and odd numbers press left buttons. The result of the task show HMM's switch cost was 167 milliseconds greater than LMM's. What is switch cost? The switch cost is compared in mean response times in trials with either non-switch trials or switch trials. And again, what is switch trials? Switch trial is, for instance, when you first have letter cues, after you respond, you will have number of Q to respond even or odd. Like it switch back and forth. HMMs were 426 slower than LMMs in response to switch trials, and 259 milliseconds slower in non-switch trials. To sum up all the findings, we can see a very surprising result that HMMs have greater difficulty filtering out irrelevant stimuli from their environment, and they are less likely to ignore irrelevant representation in memories, and they are less effective in suppressing the activation in irrelevant task sets. I guess this is contradict to most of you guys think that someone who multitasks a lot will have a better ability to switching task and perform very well. but the results from this research is showing the opposite. So the discussion of the research is saying heavy media multitasker are distracted by multiple streams of media they are consuming. So the difference between HMMs and LMM is in orientation rather than deficit. The research data suggests that LMMs have greater tendency for top-down attentional control, and thus they find it easier to attentionally focus on single tasks in face of distractions. By contrast, HMMs are more likely to respond to stimuli outside the realms of their immediate task. Maybe a greater tendency for bottom-up attention control and a bias toward exploratory rather than exploitative information processing. They may be sacrificing performance on primary tasks to let in other source of information. This is the end of the presentation. Thanks for watching.